peninsular counter does indeed require at least one receptacle. The National Electrical Code, or NEC, defines a peninsular counter as a counter that projects from two walls at a 90-degree angle. Typically, this type of counter lacks a backsplash and is open on two sides. The NEC mandates that all peninsular counters have at least one receptacle. This receptacle's purpose is to provide power for appliances, such as blenders or toasters, and to facilitate the charging of electronic devices. The receptacle installed on a peninsular counter is allowed to also serve the counter itself. This is permissible because the NEC considers a peninsular counter to be a countertop. Therefore, the receptacle can be installed in the same manner as it would be installed on any other countertop surface. It's crucial to ensure that the receptacle is installed in an accessible location. Accessibility, as defined by the NEC, means that the receptacle must be located within 6 feet of the edge of the counter. Regarding a peninsular counter that butts directly into a wall or counter intersection where an outlet already exists, the existing outlet can be utilized to serve the peninsular counter. This provides a convenient and accessible receptacle that can be used for both powering appliances and charging electronic devices. Considering electrical safety and compliance, it's essential to understand the relevant articles and sections within the National Electrical Code. Article 210 covers branch circuits, and Article 406 pertains to receptacles, cord connectors, and attachment plugs. When installing receptacles near countertops, including peninsular counters, ground fault circuit interrupter, or GFCI, protection is typically required. GFCI protection is designed to protect people from electrical shock by detecting ground faults and interrupting the circuit. Section 210.8 of the NEC specifies where GFCI protection is required in dwelling units. Generally, receptacles serving countertop surfaces within kitchens are required to have GFCI protection. This requirement extends to receptacles serving peninsular counters. The reason for this requirement is to minimize the risk of electrical shock in areas where water and electrical appliances are likely to be used together. Another important consideration is the spacing of receptacles along countertops. The NEC specifies that receptacles should be spaced so that no point along the countertop is more than 24 inches from a receptacle outlet. This ensures that appliances can be used conveniently without requiring long extension cords. For peninsular counters, the same spacing requirements apply. If the peninsular counter is longer than 24 inches, at least one receptacle outlet is required. If the counter is longer than 48 inches, at least two receptacle outlets may be required to meet the 24-inch spacing rule. When installing receptacles, it's important to use the correct wiring methods and materials. The NEC specifies approved wiring methods for different types of installations. Non-metallic sheet cable, often referred to as Romex, is commonly used for residential wiring. However, other wiring methods, such as electrical metallic tubing, or EMT, or flexible metal conduit, or FMC, may be required in certain situations. The size of the conductors used to supply the receptacle must also be appropriate for the load. The NEC provides tables that specify the minimum conductor size based on the ampacity of the circuit. For example, a 20-amp circuit typically requires 12 American wire gauge, or AUG, copper conductors. When connecting the receptacle to the wiring, it's important to follow proper wiring techniques. The black wire, which is the hot conductor, should be connected to the brass screw terminal. The white wire, which is the neutral conductor, should be connected to the silver screw terminal. The green or bare copper wire, which is the grounding conductor, should be connected to the green grounding screw terminal. It's important to ensure that all connections are tight and secure. Loose connections can cause overheating and create a fire hazard. After installing the receptacle, it's important to test it to ensure that it is working properly. A receptacle tester can be used to verify that the receptacle is properly wired and that it is providing the correct voltage. The tester will also indicate if there are any wiring errors, such as a reversed polarity or an open ground. If any wiring errors are detected, they should be corrected immediately. In summary, installing a receptacle for a peninsular counter involves understanding the NEC requirements for receptacle spacing, GFCI protection, wiring methods, and proper wiring techniques. By following these guidelines, it's possible to ensure that the receptacle is installed safely and in compliance with the electrical code. Also, remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you are not comfortable performing the work yourself. They can ensure that the installation is done correctly and safely. To elaborate further on the considerations for GFCI protection and receptacle placement, it's important to delve into the specific sections of the NEC that address these requirements. As previously mentioned, Section 210.8 outlines the requirements for GFCI protection in dwelling units. Specifically, Section 210.8 86 states that GFCI protection is required for all 125 volts, 15 amps or 20 amps receptacles installed in kitchens to serve countertop surfaces. This includes receptacles serving Peninsular counters. The purpose of GFCI protection is to detect ground faults, which can occur when electricity leaks from a circuit to ground. This can happen if an appliance or electrical device comes into contact with water or a grounded surface. When a ground fault is detected, the GFCI will trip, interrupting the circuit and preventing electrical shock. GFCIs are designed to trip very quickly, typically within a fraction of a second, which is fast enough to prevent serious injury. When installing GFCI protection for receptacles serving Peninsular counters, there are several options to consider. Firstly, a GFCI receptacle can be installed at the outlet location. This type of receptacle has a built-in GFCI that protects all devices plugged into it. Secondly, a GFCI circuit breaker can be installed in the electrical panel. This type of breaker protects the entire circuit, including all receptacles and devices connected to it. Thirdly, a combination of GFCI receptacles and GFCI circuit breakers can be used. This provides redundant protection in case one of the devices fails. The choice of which type of GFCI protection to use depends on several factors, including cost, ease of installation, and the level of protection desired. GFCI receptacles are typically less expensive than GFCI circuit breakers, but they only protect the devices plugged into that specific receptacle. GFCI circuit breakers provide protection for the entire circuit, but they require more extensive wiring. When determining the placement of receptacles along countertops, including Peninsular counters, it's important to consider the layout of the countertop and the types of appliances that will be used. As previously mentioned, the NEC requires that receptacles be spaced so that no point along the countertop is more than 24 inches from a receptacle outlet. This ensures that appliances can be used conveniently without requiring long extension cords. For Peninsular counters, the same spacing requirements apply. If the Peninsular counter is longer than 24 inches, at least one receptacle outlet is required. If the counter is longer than 48 inches, at least two receptacle outlets may be required to meet the 24-inch spacing rule. In addition to the 24-inch spacing rule, there are also requirements for the location of receptacles in relation to sinks and other water sources. Section 210.52 C5 of the NEC states that receptacles shall not be installed in a face-up position in countertops. This is to prevent water from entering the receptacle and causing a short circuit or electrical shock. Receptacles should also be located at least 18 inches away from the edge of a sink. This is to prevent water from splashing into the receptacle and causing a hazard. When installing receptacles near sinks, it's important to use weatherproof receptacles that are designed to withstand moisture. These receptacles have a gasketed cover that protects the electrical connections from water. In addition to the NEC requirements, there may also be local electrical codes that apply to receptacle installations. These codes may be more stringent than the NEC requirements, so it's important to check with the local building department to ensure compliance. When installing receptacles, it's also important to consider the accessibility of the receptacle for people with disabilities. The Americans with Disabilities Act, or ADA, provides guidelines for accessible design in public accommodations and commercial facilities. These guidelines include requirements for the height and location of receptacles. In general, receptacles should be located at a height of between 15 inches and 48 inches above the floor. They should also be located in a clay space that is at least 30 inches wide and 48 inches deep. To further clarify the wiring methods and materials used for receptacle installations, it's important to delve into the specific requirements of the NEC. As previously mentioned, non-metallic sheath cable, or Romex, is commonly used for residential wiring. Romex is a type of cable that consists of two or more insulated conductors enclosed in a non-metallic sheath. It is relatively inexpensive and easy to install, making it a popular choice for residential wiring. However, Romex is not permitted in all situations. The NEC specifies that Romex can only be used in dry locations. It cannot be used in wet or damp locations, such as bathrooms or kitchens. In these locations, other wiring methods, such as electrical metallic tubing, or EMT, or flexible metal conduit, or FMC, must be used. EMT is a type of rigid metal conduit that is used to protect electrical conductors. It is more expensive than Romex, but it provides better protection against physical damage and moisture. FMC is a type of flexible metal conduit that is used in situations where flexibility is required. It is often used to connect appliances or equipment that may need to be moved or adjusted. When using EMT or FMC, it's important to use the correct fittings and connectors. These fittings are designed to provide a watertight seal and to prevent damage to the conductors. The size of the conductors used to supply the receptacle must also be appropriate for the load. The NEC provides tables that specify the minimum conductor size based on the ampacity of the circuit. For example, a 20 amp circuit typically requires 12 American wire gauge, or AUG, copper conductors. The conductor size must be large enough to carry the load without overheating. If the conductors are too small, they can overheat and create a fire hazard. When connecting the receptacle to the wiring, it's important to follow proper wiring techniques. The black wire, which is the hot conductor, should be connected to the brass screw terminal. The white wire, which is the neutral conductor, should be connected to the silver screw terminal. The green or bare copper wire, which is the grounding conductor, should be connected to the green grounding screw terminal. It's important to ensure that all connections are tight and secure. Loose connections can cause overheating and create a fire hazard. When tightening the screw terminals, it's important to use the correct torque. The torque specification is typically printed on the receptacle or in the manufacturer's instructions. Over-tightening the screw terminals can damage the receptacle or the conductors. Under-tightening the screw terminals can cause loose connections. After installing the receptacle, it's important to test it to ensure that it is working properly. A receptacle tester can be used to verify that the receptacle is properly wired and that it is providing the correct voltage. The tester will also indicate if there are any wiring errors, such as a reverse polarity or an open ground. If any wiring errors are detected, they should be corrected immediately. A reverse polarity occurs when the hot and neutral wires are connected to the wrong terminals. This can create a shock hazard if an appliance is plugged into the receptacle. An open ground occurs when the grounding conductor is not properly connected. This can also create a shock hazard if an appliance is plugged into the receptacle. In addition to testing the receptacle with the receptacle tester, it's also important to test the GFCI protection. This can be done by pressing the test button on the GFCI receptacle or circuit breaker. When the test button is pressed, the GFCI should trip, interrupting the circuit. If the GFCI does not trip, it is not working properly and should be replaced. To further expand on the requirements for electrical safety, it's important to understand the role of overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect electrical circuits from overloads and short circuits. An overload occurs when too much current is flowing through a circuit. This can happen if too many appliances are plugged into the same circuit or if an appliance is drawing too much power. A short circuit occurs when a hot wire comes into contact with a neutral wire or a ground wire. This can cause a large amount of current to flow through the circuit, which can quickly overheat the wires and create a fire hazard. Circuit breakers and fuses are designed to trip or blow when an overload or short circuit occurs. This interrupts the flow of current and prevents the wires from overheating. Circuit breakers are reusable devices that can be reset after they trip. Fuses are one-time devices that must be replaced after they blow. The size of the circuit breaker or fuse must be appropriate for the size of the circuit. The NEC provides tables that specify the maximum size of the circuit breaker or fuse based on the ampacity of the circuit. For example, a 20 amp circuit typically requires a 20 amp circuit breaker or fuse. When selecting a circuit breaker or fuse, it's important to choose one that is listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. UL-listed circuit breakers and fuses have been tested to meet safety standards and are more likely to perform properly. When installing a circuit breaker or fuse, it's important to follow the manufacturer's instructions. The circuit breaker or fuse should be installed in a panel board that is properly grounded. The panel board should also be labeled to indicate the circuits that are protected by each circuit breaker or fuse. In addition to overcurrent protection devices, it's also important to use surge protection devices to protect electronic equipment from voltage surges. A voltage surge is a sudden increase in voltage that can damage electronic equipment. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices are designed to absorb or divert voltage surges, protecting electronic equipment from damage. Surge protection devices are available in a variety of forms, including power strips, wall-mounted units, and whole-house surge protectors. Power strips and wall-mounted units provide surge protection for individual appliances or pieces of equipment. Whole-house surge protectors provide surge protection for the entire electrical system. When selecting a surge protection device, it's important to choose one that is rated for the amount of surge current that it can handle. The surge current rating is typically expressed in amps. It's also important to choose a surge protection device that is listed by a recognized testing laboratory, such as UL. UL-listed surge protection devices have been tested to meet safety standards and are more likely to perform properly. When installing a surge protection device, it's important to follow the manufacturer's instructions. The surge protection device should be installed in a location that is easily accessible. It should also be connected to a properly grounded electrical outlet. To summarize, electrical safety is a critical aspect of any electrical installation. It's important to understand the NEC requirements for receptacle spacing, GFCI protection, wiring methods, overcurrent protection, and surge protection. By following these guidelines, it's possible to ensure that the electrical system is installed safely and in compliance with the electrical code.